Hello everybody. I'm so pleased to be joining you here today at the Enterprise Wearable Tech Summit. And on behalf of my colleagues at PTC, we're very pleased to be a platinum sponsor of the summit. What I want to share with you today is some of our thinking about how to bring wearable tech, and I'd say digital in general, to the front line. And to set the stage, I want to reflect on what's happened in the last 6 or 7 months since the coronavirus showed up. There was this really amazing experiment conducted on a global basis with little planning and preparation, where we sent a massive workforce home and said, try to make it work from home. And we really had almost no trial runs or anything like that. And I think many of us would say it actually worked pretty well. We're actually quite productive working from home. In fact, in some ways we're more productive because we're not wasting hours in traffic commuting to the office. We're not wasting hours in the airport and on airplanes traveling around the world. It really is kind of productive to work digitally. In fact, I think you could say, I'm not sure we should declare a winner, but if you wanted to say what really is a winning concept coming out of the COVID era, it would be digital. Because when things are digital, it doesn't really matter where you are. You can do your work from anywhere. And I think this realization really accelerated our digital transformation journeys by many, many years in just a few months. And I think you'd probably agree with me that the digital genie is not going back in the bottle. We're never going back to the way it used to be before the coronavirus showed up. Now, it's easy for me to say that, and it might be easy for you to agree because we're knowledge workers. That minority of the global workforce that mostly works behind a computer all day long. If you were a frontline worker, like let's say a factory or plant worker, or somebody at a construction site or out at a customer site, or a policeman or fireman, or somebody in the food service industry or healthcare industry, you might say, what are you talking about? Digital didn't do anything for me. I'm not working from home. And so I think we're going to need to find a way to prioritize bringing this digital superpower to that much larger frontline workforce that really isn't accruing any of the benefits of it today. But in order to do so, we're going to actually have to digitize that frontline setting. Now, why would we digitize the frontline setting? Well, first of all, we have to, because frontline workers can't work from home. You can't have assembly workers assembling automobiles at home. You can't have construction workers building homes from their home. You can't have policemen and firemen working from home. You can't have food service workers waiting on tables from home. It just doesn't make any sense. We're going to need to bring digital to the front line. And we have to do it in a different way because these workers don't stare at computers all day, and they don't want to stare at computers all day because it's distracting them from their actual work. So we're going to need to find a way to let the real world be the canvas for our digital information rather than the computer screen. And then finally, while we have great tools for collaborating and publishing information and so forth, we're going to have to find some parallel universe version of these tools that work for knowledge workers against this canvas of the real world. Now, fortunately, there's been some real progress made on that, including here at PTC. So, for example, a lot of us use Zoom or various different types of video calls to collaborate with each other. And, I see you, you see me. But if I'm a frontline worker and I'm looking for help with some problem in front of me, I don't want you to see me. I want you to see the problem. And I want you to be able to interact with me in the context of the problem, not in the context of my face. So here's a good example of our Vuforia chalk technology working in sort of a spatial setting of the frontline world. So this particular young woman has some kind of a question or needs some help, and this expert on the right side is maybe 1,000 miles away, and he's talking to her, but also perceiving her frontline world and interacting with it. And you'll notice when he makes marks, he's actually making marks on the world, or actually a 3D model of it being dynamically captured, because the marks stick to the background, not to the foreground screen. And this is really important because otherwise, if she pointed the phone in the wrong place, the information would be deployed incorrectly. So this is an example of having a video call, if you will, where on one side it's a computer screen, or in this case a phone, and on the other side the canvas really is that real world background that the woman needs assistance with. Let's look at another example. We're all used to using Word to create documents and PDF files, and we're used to web pages and whatnot as a way to publish information and instructions to people. Now again, as a frontline worker, I don't want any more documents. I don't want any more PDF files because they're distracting me from my work. What I want is information that's presented to me in the context of the work I'm doing. So here's a company, BAE Systems, that's assembling hybrid bus batteries using, in this case, a HoloLens 1 wearable. And the information that's guiding the worker is floating right there in the context of the work that she's doing, and really step-by-step instructions to match the digital with the physical world that she's working on, just to keep the two aligned, and you'll do a good job. We're also, of course, capturing the information that each step has been done, and we know how long it took to do each step and so forth. So we get also a good feedback and, if you will, quality control loop. Let's look at another example of YouTube videos. Now, many of us have used YouTube videos as sort of a how-to way to capture and pass on information. Now, the problem with YouTube is it captures both the foreground information and the background at the same time. So I might say to you, hey, can you explain to me how to make bread? And you might create a YouTube video of you making bread in your kitchen. But what I wanted to know is, how would you make bread in my kitchen? Separate the making of the bread from which kitchen it's deployed into. And again, we have great technologies like Vuforia Expert Capture that, for example, would allow an expert worker to put on a wearable device, fire up the software, and go about his job. And we're capturing, where is he? What is he looking at? What is he seeing? What is he hearing? He's issuing some commands here and there, and we're basically capturing a digital record of everything that happened. And so when he's done with the process, here he said, I want to do another step. Okay, that would be step 6 in the sequence. He's placed some points. When he's done, an editor can take this information, pretty it up a little bit, and prepare it to be redeployed across a number of different devices. Now, when it's time to reuse this information, this capture, we've separated the information that was captured from the background, and we've placed the information in the context of this particular background. Happens to be the same background, but it could be a completely different factory where we would redeploy that same information into different places in the context of that second factory. So here we're explaining to her step 6, and now we're saying, come over here, and you'll do step 7 over here, and here's what you need to do step 7, and so forth. And this young woman might be educated by an expert who retired 2 years ago. But what we've done is digitally captured that information and can now deploy it against any physical frontline backdrop, if you will. So I've shown you a couple of examples of how we can have, in particular, augmented reality technologies that do the same kinds of things as Zoom calls, as PDF and web publishing, or as YouTube videos. But there's actually a bigger opportunity here. And I really like this 4P framework. I didn't come up with this framework, but I've adopted it because it's a good way of thinking about it. It starts with the idea of products. These are the things, the machines, the robots, the assets, the equipment that would be in a frontline setting. The second thing is the people. These are the actual workers that are in a frontline setting. The third thing is the place, an understanding of the frontline setting itself, the spatial understanding. And then finally, the process that might involve people and products working together in a place. So this model really looks at the different dimensions of the front line and allows us to think about how would we go after them. So let me show you some examples. And I want to build off how PTC thinks of the world. So if you've seen our logo, it's kind of this interesting shape. But this is actually a white P representing the physical world on top of a green D representing the digital world. And it comes from this concept of yin-yang, two forces that are the opposite of each other, but together make the picture complete, like male and female, or hot and cold, night and day. So what we want to do is create on the digital side a mirror image of what's happening in the physical world, for example, of this factory. Now, how do we create these digital models that map to the physical world? Well, if it's a brand new factory, we can define it digitally. Of course, many factories aren't brand new. They've existed for dozens or hundreds of years in some cases. And in that case, we could capture the digital model from the physical space using depth sensing cameras and photogrammetry and things of that sort. Let me give you a couple examples of how we create digital twins of factories, for example. So here's an example using our Onshape software. And what we have is several different engineers working together to define a new factory. And I'm going to take you to that factory in a minute. But here we're still in the definition phase. And we have an engineer in Tokyo trying to place this yellow pick-and-place robot into this work cell. Meanwhile, there's an engineer in Boston, perhaps working for a different company, trying to replace a screwdriver, automated screwdriver kind of assembly. And these two machines are going to have to interact with each other and both coexist within that same work cell. So a factory is an amazingly complicated design, but we have tools that allow different people to work together and bring their contributions in, deploy them next to each other, test them out, almost like software engineers would do with software. And then if I'm the integrator, the guy in charge of building the factory, I can see the different changes that each engineer is wanting to make, and I can decide, if I want, to bring those changes together, to sort of merge the branches, if you will. So I'm going to merge in the Tokyo branch, and I'm going to merge in the Boston branch into my factory, and now I've automated this particular work cell. Now I can take it to the next step and actually use software that would allow me to program these robotic operations before they ever physically existed. So here I have the ladder logic and all the PLC control statements to actually, control who does what and what time frames and what triggers the different actions and so forth. And what I've been able to do here is create an amazingly sophisticated digital definition or model, if you will, of a factory we're going to go build. And I can take it to the next level and step back and see that whole amazing automated factory running digitally before it ever exists. Now, again, this is great. This is the way it should be done. But in many cases, the factory already exists. It's too late to do this. What do we do then? Well, here's a different example built with our partner Matterport using their depth sensing camera technologies, where we go into the actual factory. This is that same factory, but now it already exists. And we're using depth sensing cameras to create a 3D model of this factory that we can go navigate. You'll see some of the same types of robots here in these work cells as we were just programming. And again, this is a 3D model that I can navigate through, created very fast and easy using photogrammetry and depth sensing cameras. So this is also a great way to get an understanding of the place or the space, a spatial understanding of the environment that we're working in, because we're going to reference that many times as we track the actions of things and workers in the overall process. Okay, so now that we have a digital twin of a physical work site, we can do some amazing things. We can use sensors and PLCs and other data sources to collect data from the physical world and bring it into the digital world so that we can monitor what's going on. And now that we have this data, we can analyze it using different types of analytics and rules engines and AI and ML and you name it. We can really get an in-depth understanding of what is happening and begin to predict, if necessary, what might happen next. And in some cases, predict bad things and then try to circumvent them. So we can provide instructions back into that environment, in order to optimize the working of both machines, and I'll show you in a bit, workers. So what we're really doing is creating a closed loop, interactive monitoring and optimization loop between a physical site and a digital site. So let's take a look at, how that looks and feels. So we start with the concept of the places. So here's an actual model of a place at our PTC headquarters, our so-called reality lab. And it's the room in the background we're going to enter in a minute. And it's got various different machines in it, and you're going to see in a second workers as well. Now in this case, we wanted a real-time digital twin, 3D digital twin. So you see there are people walking around in this space, and I'm in virtual reality mode, being able to fly through it and look at different perspectives. Now I'm back in the real world mode as if I'm in the room. Now I'm back in the virtual mode, looking again from 1,000 miles away and showing you just like how similar these different concepts of the digital place and the physical place really are, and the ability to equivalence the digital and the physical actually in real time. It's a powerful concept. Now let's take a look at the things or the products that are happening or involved in a place like that. And here's a fun example of a product or a thing actually having a digital human-machine interface We see it with our AI-based model tracking, model recognition and tracking. And now this machine is exhibiting its human-machine interface so that this particular guy, again, in this case wearing a HoloLens too, can interact with it. So the idea is that the machine in this digital virtual representation is really reviewing its entire user interface, using, in this case, augmented reality. Let's look at the concept of how to guide people. So here's an example of, it's a short loop of a video that's going to keep playing because I got to point some things out. The instructions being provided to the worker are in the upper right. It's basically turn this cap clockwise and lift it off. Okay? Now, what we're doing is using analytics to actually observe the hand. And the fact that the hand is colored green is because we observe it's doing what we expect it to do. If the hand were turning counterclockwise, then it would be red. We'd be saying you're using the wrong motion here. And then finally, the green check mark that happens at the end of this video clip is actually using computer vision to determine that the task was completed successfully because this little probe, if you will, looks correct now that the cap has been removed. I can see that the cap is removed, in fact, using computer vision technology. So this is a great example of both guiding, but also doing quality control on the work of a human that's within that virtual space. Let's take a look at a fun example of a process that involves people and products working together. So here is a conventional robot, and this young woman, Anna, actually from our reality lab, is going to program a shared understanding of motion in space with this robot. So she's using augmented reality to place some control points on the floor and move them around, in various different directions, elevate them. And she's sweeping a path that is digital, but she can see it thanks to augmented reality. And of course, the robot sees it as a stream of XYZ coordinates through its connectivity. Anna creates a start button and wires it to the beginning point, hits start, and then the robot is asked to go swing that same arc using, again, a stream of XYZ coordinates that Anna saw as augmented reality. So again, it's a shared spatial understanding, even though the human is using sight and sound as their senses, and of course the robot is using connectivity through its Ethernet connection. So I tried to show you some examples here of digitizing an entire frontline space, really the concept of spatial computing, understanding the place, the products, the people, and the process, and how it all works together. Now let's join that all and look at, for example, what could we do with it? And I call this concept spatial analytics. And so now this is that same process we were watching earlier. We're going to pick it up, but this time we're going to turn on our analytics. And we're going to actually do the same kind of like stopwatch work that Frederick Taylor would have done 100 years ago. And we're analyzing how much time this worker spends in different zones, different spaces, if you will. And now we're going to analyze actually how well the process works. So we've created some zones, and now we're going to number them step 1, 2, 3, 4, and 5. And as Anna works, and she's been, as you can see, made invisible here and no longer a real person, so for privacy reasons. But we're able to get a waterfall of how much time is spent by the person, how much time by the machine, where the activity happens in this place, and really get a super deep understanding of how this process works. So I'm very excited about augmented reality and IoT and AI and AR and VR all coming together in this ability to digitize a frontline workspace so that we can optimize it and make it ever more efficient. Okay, so with that, I'm going to wrap up my talk. If you have any questions or comments, feel free to come back to me at jim@ptc.com. And with that, I'll be happy to take some questions.